Okay. Good day, grade 8 students. Good day, viewers. We are now in our last week of our session, quarter 4, week 9, wherein we need to illustrate the probability of a simple event, which is theoretical and experimental. So last time we talked about probability, wherein we're studying about the chances that a certain event may occur. So there are two types of probability. The first one is the theoretical, and the second one is the experimental. So when we talk about theoretical probability, it is merely lies with the formula P of E is equals to cardinality of event over cardinality of sample space. So uh, so meaning to say each of the event has a chance to occur or has a probability of chances. Now, in experimental probability, we also, in experimental probability, this is depend on the experiment conducted. So it depends on the occurrences of a certain event with the number of trials. So later, we're going to illustrate the difference between the two. So experimental probability is also known as empirical probability. So in experimental, it is more on actual experiments, while theoretical is based on our theoretical probability of formula, which has a formula P of T, probability of a simple event is equal to cardinality of event over cardinality of sample space. Okay, so let's talk about with the first situation. What is the probability of getting ahead in tossing a coin? So in theoretical probability, let me show it. So in theoretical probability, you have P of E is equals to cardinality of event over cardinality of sample space. Wherein our event is we want head, so that is cardinality of 1. In sample space, head and tail, the cardinality is 2. So you have P of E is equals to 1 over 2. So in theoretical probability, getting ahead is 1/2. However, in experimental, so here is an example of experimental. Let's say we want 5 trials. We want 5 trials and we actually toss a coin, and here are the results. So in first trial, you have head. Second trial, head again. Third and fourth and fifth, you have tail. So we're going to base the occurrences on the result of our experiment. So we want head, our event head, and according to the table, the cardinality is 2. So your sample space here is 5. So you have now P of E is equals to 2 over. So you have 2 over 5 getting head. Now, there are instances that you cannot get head or you cannot get tail. So other instances, it can be, uh, let's use another for that. For another trial, you have here tail, have here tail, 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 tail. So here, probability of E, so cardinality of getting head is 0. So we want head. So you have here 0 over 5. So the probability of getting head is 0. If if the result doesn't show head, There are instances also that all of the result is head. So we can have, let's use another color. So you can see another trial, one head, two head, uh, three head, uh, four head, and five head. So if we want an event head, and the cardinality is 5, meaning all of the 5 trials you get head. So P of P is equals to 5 over 5. That would be 1 of getting head. So it depends on the experiment. If the head doesn't occur, you have 0. If all of the trial shows head, it's 1. So, and so on and so forth. Now, let's have the theoretical probability for this. So the second example, so for theoretical, you have P of E, N of E, cardinality of sample space. So you still have 1/2. Your event here is tail. Cardinality is 1. So sample space again is 2. So again, we want head and tail. So 1/2. But here in our experiment, your event tail is 3. Our sample space is 5. So P of E is 3 over 5. Getting tail. Now, if you want to determine if you're correct, probability of head plus probability of tail must be equals to 1. So for head, 2 over 5 plus tail, 3 over 5. So that is 1 equals 1. So correct. So the characteristics for probability does not compromise in our empirical probability. How about probability of getting prime? So what are the prime again? You have 2, 3, 5. So cardinality is 3. And the sample space is 6. So probability, N of E, N of S, that's 3 over 6, 1/2. So getting prime. So the probability of getting prime is 1. Now, in empirical or experimental rather, sorry. In experimental probability, we base on the table. So what are the primes in our table? You have 3, you have 2, and you have 5. So cardinality is 3, sample space is 5. So P of E is equals to 3 over 5. So take note, there were times they were equal. Sometimes experimental and theoretical are equal. Okay. Sometimes are lesser or greater. So here. So non-prime, for non-prime, the cardinality of non-prime for non-prime is we have 2. Cardinality Non-prime is 2. So, prime plus non-prime must be equal to 1. So, 2 pip, 3 pip for non-prime rather. Non-prime 3 pip. 3 pip plus 2 pip equals 1. 5 over 5 equals 1. Okay. So, we still have the characteristics of probability. You get the probability of the other event or non-event, the sum is equal to 1. Okay, for even number, for theoretical, you have 2, 4, 6. Cardinality is 3. Sample space 5. So P of E is cardinality of event over sample space. So that's 3 over 5. For getting even number. Okay. Now, how about experimental? So we want an even number, n of p, 2, 4, 6, so we still have 3. So cardinality sample space is 5. So P of E is 3 over 5. So prime, even plus non-even. Even plus non-even equals 1. So 3p plus 2p equals 1. 5 over 5 equals 1. So here, odd number is 3. Recall that that is 135. We don't have 7. Sample space is 6. So P of E is 3 over 6. Correction. This is 3 over 6. 3 over 6. 1 half. This is 1 half. Okay. So 1 half 3 over P. In theoretical, 1 half. In empirical or experimental, 3 over 2. So here, if we're going to use it, the cardinality is 3. Sample space is 5. So P of E is 3 over 5. Based on the experiment, it's 3 over 5. Now, let's talk about the head and a tail. Head and even number. So, from our previous lesson, for coin times cardinality of die, that would be 6 times 2, that's 12. So, cardinality of sample space is 12. We want even number and head. So, 2h, 4h, 6h. So, the cardinality is 3. So, you have here P of E is equals to 3 over 12 or 1/4. That's the cardinality for getting, probability for getting head and even. Head and even number. However, what if we have experimental? So in experimental, by the way, this is theoretical. In experimental, we want even and head. So the even and head is only 2. Sample space is 5. Cardinality of sample space is 5. So P of E equals 2 over 5. So that's the difference between the two. So the last one, tail and odd number. So in theoretical, tail and odd number, 1 tail, 3 tail, 5 tail. Cardinality of 3. So P of E, by the way, the sample space is 12. Cardinality of sample space, we still have 6 times equals 12. 6 for die, 2 for coins. So that is 3 over 12. And that is 1/4. For getting odd and tail. Here, let's have here, we want odd and tail. So we only have one, which is 15. So cardinality sample space is 5. So in experimental, P of P equals 1 over 5. So again, theoretical probability is based on cardinality of sample space, cardinality of the ratio of cardinality of an event equals, okay, let's go. Ayan. Okay, so when we talk about theoretical probability, that is equals to probability of an event is equals to cardinality of event over cardinality of sample space. That's theoretical. Because theoretical probability is ideal probability. All of the possible outcomes has unequal chances. In experimental, there's possibility that some of the event does not occur because it depends on the experiment, depends on the result of the experiment. Now, let's talk about the simple problems. I guess it's simple problems that deals with the probability. Okay, so let's have our first example. Wilbur wants to play marbles with Mon. There are 3 blue marbles, 4 green marbles, and 6 orange marbles. What is the probability will Mon get blue marbles? So our sample space is 13. So how come that the sample space is 13? You have 3 plus 4 plus 6 is 13. There are 13 marbles. So outcome over sample space or probability of an event. So your outcome probability, or the cardinality of this is 3. So, or you have n of e all over n of x. So you have here 3 over 13. We're getting blue marbles. So you have 3 over 13 for getting blue marbles. Then the next one, for green marbles, you have 4. You have the cardinality of 4. So you have here cardinality of E over cardinality of X. So that's 4 over 13 for getting green marbles. Your chance to get green marbles. Getting green marbles. Now you want orange. What's the probability will Mon get orange marbles? So out of 13, there are 6. 6 orange marbles. So the cardinality here is 6. So you have n of E all over cardinality of sample space. So 6 over 13. As you can see, our fraction doesn't have to reduce in lowest term because they are already simplified. So getting orange marbles. So according to our note, verify if the answer is correct, sum up the probabilities, and it should be equal to 1. So probability of getting blue plus green plus orange equals 1. So 3 over 13 for blue, 4 over 13 for green, and 6 over 13 for orange. So since they are similar fraction, you just add that numerator. So 3 plus 4, 7 plus 6, 13. 13 over 13 is 1. So the probability we have is correct. Now, what if we want blue and green? So take note, since it is n means you want blue and green. So you have here, have to add blue and green. So blue and green, you have 7. So 7 over 13. Okay, so 7 over 13. So blue and green marbles, you have 7. So the probability of getting blue and green marbles is 7. So the outcome is 7. Now, let's have the probability that get blue and orange. I think we have a correction here. It's or. Let's change it into or. Blue or. Must be blue or. Ayan. Because or in mathematics means addition. So let me change or. Blue or orange. Ayan. so, so we have addition. Okay. So or means add. In set language set notation or means add. So you have here 3 plus 4. Yeah, so we can use now. We can use the plus. So the outcome, probability, cardinality of E over cardinality of sample space. So you have 7 over 13. So Wilbur has a probability of 7 over 13 in getting blue and green marbles. Blue or green marbles. That's blue or green. Okay. How about that Wilbur will get blue or orange? So you have here 3 plus 6. Since we use the word or, it would be plus. So 3 plus 6 is 9. So that would be 9 over 13. So Wilbur has a probability of 9 over 13 in getting blue or orange marbles. Yeah. And the probability that Wilbur get green and orange. Or green or orange. That's the right term. Green or orange. So or means plus. So you have here 4 plus 6. Because in our previous example, green has 4, orange has 6. So 4 plus 6. So N of E all over N of S or cardinality of E and S. You have here 10. So 10 over 13. So Wilbur has a probability of 10 over 13 in getting green or orange marbles. Now, let's have this one. Jen, Moon, and Wilbur decide to go on a trip. One local trip and one abroad trip. For local trip, the choices are La Union, Palawan, Cebu, and Davao. While for the abroad trip, the choices are Vietnam, Rome, and New Zealand. What is the probability of choosing La Union or Vietnam? Let me change the question. So we can use or, we can use addition. Okay. So, in getting the probability of choosing La Union or Vietnam, first let's apply the fundamental counting principles, FCP, fundamental counting principles. Sorry, it's a typo error. And we have on the spot edit. Okay, for local trip M, we have 4. For abroad trip N, we have 3. So 4 times 3, we have 12 trips. Okay. Oh, so how are we going to deal with this? One local trip and one abroad trip. So they can choose two at a time. Hmm, okay. So here's the strategy. We have 12 trips. The outcome, one trip La Union and Vietnam. And one trip La Union or Vietnam. So we want La Union or Vietnam. So you have here, N of E is 1. La Union or Vietnam. So 12. So the probability of choosing La Union or Vietnam is 1 over 12. 1 or 12 of 6 or now, if we're going to ask the uh, percentage, what if the question asks you the percentage of probability? What will be, what is our answer? So you need to convert decimals, fractions into decimals. So you have here 12 by 1. So since we cannot divide, that's 0. Then add decimals to decimals, so 0 again. So you have here 0. Then you have 100. So 8 would be 96. 4, that would be another 0. So you have 3, 36. So this is repeating. And then multiplied by 100%. So the percentage now is 8.33. The percentage of probability is 8.33%. Now, how about the others? What is the probability of the other trips? And what is the uh, percentage of the other trips as well? So, it's up to you. If you want to answer that question, you may leave that in the comment section. So if you have question about this, please feel free to put it in the comment section. See you next time. Bye.